Okay, let's do a video on simplifying square roots. Let's start with square root 135. Remember, our goal is to write this as the product of a perfect square times an irrational number. Okay, so if we can find a perfect square that's a factor of 135, then we're going to be in great shape. So first thing we need to do then is consider, does 135 have any perfect squares? Well, off my head I can't tell. So one thing I can do is make a factor tree. So if I do 135, usually I start with dividing by 2, but since this is an odd number, I can't divide by 2. It is a 5, so I could divide 135 divided by 5. So yeah, you're going to have to do a little math work here. That goes in twice. 2 times 5 is 10. 3, bring down your 5. 27. Okay, so that's 5 times 27. And then I told you in class I like to bring down that 5. And then 27 is 9 times 3. Well, I just found my perfect square. But if you want to keep going, you can factor it all the way. 5 times 3 times 3 times 3. And remember I said if you can find the pair, you can find the square. Here's the pair, 2 3s. So now I'm going to rewrite this as square root 5 times square root, actually I'm going to not do that, sorry. I'm going to rewrite this as square root 9, because that's the perfect square. And then what's left over? A 3 and a 5. Square root 15. And it is true that 9 times 15 equals 135. So I found my perfect square. So let's go back up here. What I wanted was a perfect square times an irrational number. So my perfect square is 9, and then the other factor is 15. Square root 9 times square root 15. From here there's only one more step. Simplify the 9 into an integer. Square root of 9 is the exact same number as the integer 3, and then keep your irrational number. Then as a last step, you should always just check, does 15 have any factors that are perfect squares? It does not, so you're done. Let's do another one. Let's try square root of 96. Remember, what I'm looking for here is to do the square root of a perfect square times the square root of whatever, an irrational. So basically I'm looking for a factor of 96 that's a perfect square. Now the easiest way to do this would be to look at my list of perfect squares and see if any of them are a factor of 96. Remember, my perfect squares: 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, and so on. Are any of these numbers factors of 96? Well, it looks like 4 might be a factor. Let's check. 96 divided by 4. 4 goes into 9 2 times. 1, bring down your 6. Yeah, so I could do root 4 times root 24. 4 is a factor. But I told you in class, if you're ever going to use 4, make sure you also check for 16 just in case. So let's see, does 16 go into 96? It's kind of an awkward long division problem, but let's see. I know 16 times 2 is 32. 16 times 3 is 48. Let's skip 16 times 4, maybe 16 times 5. That's 0, carry your 3. 80, oh, I'm getting close, right? It looks like it's 16 times 6. Can you still see that? Yeah, 16 times 6 36, carrier 3, 96. Oh, so actually 96 is 16 times 6. There's my perfect square. So, for my perfect square, I'm going to use 16. And then 6, because 16 times 6 is 96. Now I want to simplify the perfect square into an integer and keep the irrational number. And then as a final step, does 6 have any factors that are perfect squares? No, it does not. Now you could also do this with a factor tree. This one's a little challenging with a factor tree because there are so many 2's involved, but let me show you just in case you like factor tree best. So let's say you start with 96. I've told you I like to start by dividing by 2 if it's an even number. So that would give you 2 times, you have to trust me on this, 48. Then I bring down this 2. 48 splits into 2 times 24. I like to bring down my 2's. 24 is 2 times 12. Right, I'm still bringing down these 2's. That's 2 times 6. Bring down all these 2's again. And that's 2 times 3. Okay, so if you find a pair, you find the square, right? So here's a pair. Square root 4, or it's 4, so I'm going to put it under a radical. 4. And what's left over. So here are my 2 pairs. 4, 4. Notice I'm putting them under a radical. And then this is 6. Is it true that 4 times 4 times 6 equals 96? It is. Is it true that radical 4 times radical 4 times radical 6 equals radical 96? Yes, that's true also. So in this case, I came up with 2 perfect squares, and that's okay. So let's go all the way back up here. I could say that I had square root 4 times square root 4 times square root 6. Is it true that root 4 times root 4 times root 6 equals root 96? Yeah, it is. If you do the work, you'd find out that was true. Now I simplify my perfect squares into integers. 2 times 2 times root 6. 2 times 2 is 4, root 6, which is just what we got last time, the other way. Okay, another example. Let's do, 567. Square root 567. Again, I want this to be the product of a perfect square times an irrational number. Okay, so are there any factors of 567 that are perfect squares? Let's find out. So I'm assuming you don't know this off your head, which is okay. You know, I said I like to start by dividing by 2 in a factor tree. That's not going to work because this is not an even number. Can't divide by 5 because it doesn't end in a 5 or a 0. Another trick to check for is if the digits of the number add up to a multiple of 3, then the number is divisible by 3. Let me say that again. It's just a little trick. If the digits of the number add up to something that's a multiple of 3, then the number will be divisible by 3. So 5 plus 6 is 11, plus 7 is 18. These digits, this is just again a little trick. These digits add up to 18. If the digits add up to 18, that's a multiple of 3, then that means I can divide this number by 3. Alternatively, I could have just divided by 3 and seen if it worked. Okay, remember I told you, you're going to have to know how to do long division to do these problems. So here's another long division situation. 3 goes into 5 one time. 5 minus 3 is 2. Bring down your 6. 3 goes into 26 8 times. Also, if you don't know your multiplication and division, you want to brush up on that. 26 minus 24 is 2. Bring the 7 all the way down. and 3 goes into 27 9 times. Okay, so now I have 3 times 189. Okay. 189, it's not divisible by 2, it's not divisible by 5. If I add the digits, 1 plus 8 is 9 plus 9. That's 18, it's going to be divisible by 3. Also, can you just see 18 divides by 3 and 9 divides by 3? If I wanted to do this long division kind of in my head, 189 divided by 3, I can see 18 divided by 3 is 6, 9 divided by 3 is 3. You can do that one in my head. But if you want to write it out, same thing. 18 divided by 3 is 6. Multiply 0. Bring down your 9. 3 goes into 9 3 times. So it's 63 times 3. Okay, 63. Oh, that's 9 times 7. All right. Hey, and I think I just found a pair, and I've got a 9, which is a perfect square. 7, almost done here. 3, 3, 9 is 3 times 3, 7. If you find the pairs, you find the squares. Here's a pair. So now I'm going to rewrite this with radicals. Square root 9, because 3 times 3 is 9. Square root 9, because 3 times 3 is 9. Square root 7. Is it true that root 9 times root 9 times root 7 equals 567? I should probably just check. 9 times 9 is 81. 81 times 7, 56. Yeah, 567. Okay, good. I did it right. So root 9 times root 9 times root 7. So let's go back up here. My perfect squares are root 9 times root 9 times root 7. Now you change them, the perfect squares, into integers. 3 times 3 times root 7. That equals 9 root 7. There you go. Let's do one more quick one. Let's do square root of, let's see, 68. So square root of 68, I don't know that off my head. I wonder, though, it's a small enough number. Instead of factor tree, maybe I should just check. So here we go. We want a perfect square times irrational. I'm hurrying a little bit because I'm almost at 15 minutes. So 68, here are my perfect squares. I know it's not going to be bigger than 36 because 36 times 2 is 72. Does 4 go into 68? Let's see. 1 times 4 is 4. Yeah, it goes 17 times. I should check for 16. I think I'm going to use 4 and 17. But let's check for 16. Let's see, 16 times 3, we know that's 48. 16 times 4, I'll do it down here. Let's see, that's 24, carry your 2. 64. No, since 16 goes into 64, there's no way it's going to go into 68. So I can use 4 times 17, because 4 is on my perfect square list. So here I have my root 4 and my 17. Is it true that 68 is the root 68 is the square root of 4 times square root of 17? 17 times 4, 8, carry your 2. Yes, 68, that works. Now rewrite this as an integer, 2. That stays irrational as root 17. And that's my answer. Hope these helped.